So we're on question 5 on homework 13, and we're studying the binomial distribution using Stirling's approximation. So what we're going to do is we're going to choose some, or at least in part 3 and part 4, we're going to choose some from constant fraction of n, and we're going to see how often we get that fraction of n number of heads, and we're going to try to plot graphs in terms of both n and the fraction from 0 to 1 for the fraction and from 1 to 100 for n. Right? So first of all, let's do question 1. Question 1 asks us to calculate the exact probability that we get k heads, right? So this is very simple. How many different ways can we get k heads? And choose k, right? For n coin tosses, you choose k of them to have k heads. So we have n choose k. And how many different, what's the probability of each of these sample points? Well, since the coin is a fair coin and we have n coin tosses, the probability of any sample point is going to be 1 over 2 to the n. So this is the probability of getting k heads. Right? Now let's look at part 2. We're using Stirling's approximation so that every single thing, first of all, we're going to use Stirling's approximation. We'll get a bunch of exponentials out of the factorial, and we just have to remove the e from the whole thing, which is fairly simple. So we have probability of s is equal to k is equal to, let's take 1 over 2 to the n out here, times n factorial times n minus k factorial times k factorial. Right? And this is approximately equal to, by Stirling's approximation, this is equal to root 2 pi n over e to the n divided by root 2 pi n minus k over e to the n minus k times k. Nope, this is, extend that as root 2 pi k over e to the k. So let's cancel 2 pi out with 2 pi. We notice that we have e to the n, 1 over e to the n on the numerator, and we have 1 over e to the n minus k times 1 over e to the k on the denominator. So we have 1 over e to the n minus k times plus k, and we have, so actually let me just write this out. So we have 1 over 2 to the n times root of n over 2 pi n minus k times k times n to the n divided by, I'm just pulling out all the n and k terms out, times k to the k times 1 over e to the n divided by 1 over e to the n minus k times 1 over e to the k. So 1 over e to the n minus k times 1 over e to the k is just equal to 1 over e to the n. So these two get cancelled out, which is equal to, what I want to do now is I'm going to split. Okay, let me do that in 2 steps. 2 pi n minus k times k. I'm going to pull the 1 over 2 into the 1 over 2 to the n into the n to the n, and we're going to get n over 2, and I'm going to split n to the n into n to the n over 2 to the n minus k times n over 2 to the k divided by n minus k to the n minus k times k to the k, which is just equal to root of n over 2 pi n minus k to the k times, I'm going to pull each of these fractions, each of these numbers into their respective fractions, times n over 2 times n minus k to the n minus k times n over 2 times k to the k. So it's fine if you didn't reach this point and you just left it at this point. It's okay, because that's what the question is asking, but writing it in this form will simplify things for you later on. So yeah, that's it for question 1 and 2 for part 1 and 2 of question 5.